Why, hello there. Get down here. Why, hello. This is a patent by Nikola Tesla called the Bifilar Coil. It was also designed to be a ferromagnetic coil. I think, as the patent would say. It's very simple design. It's basically two windings. You can see I started from the middle here, but these two actually spliced it later on. So it was one coil I started off with, wound it together, then after slowly and taping this structure down, then spliced it and then reattached some wires on the ends. But basically what happens is that you have wires that go to the outside, one reconnects to the inside, and the other one becomes your outside terminal. So you have an inward terminal and an outward terminal. The two, when a current is placed on this, it makes the electric field around the wires oppose each other. Though the current runs in one direction within the wire, but it has opposing electric fields. And it's very interesting because what it does is it makes a very strong electromagnet. And that's the reason why Tesla was making this. So just going through this, we have different effects. Like if you go on the inside, I have this neodymium magnet I'll use for alignment purposes to demonstrate. We put this in here with a 9-volt battery. And it will stand up every time, so it has a direction up and down. But when you place on the side here, I can get something that's smooth. It's kind of polarized. That's interesting. That it polarizes towards the center. Let me put it perpendicular. See how it turns. So again, just to make sure that's on camera correctly. Turns. So it has a direction of magnetic force. It's kind of like a toroid. So it's very interesting that you can get that kind of geometry in this kind of shape, but this can also change depending on where you're at in the coil. I don't know if it's the same every time. Let me see if there's a way that we can. Yeah, I think it always points, like the average points inward, because it's very interesting. If I put this to the outside, let me put it perpendicular, is that there is no magnetic potential out there. It does not interact. So you can get a clear image that I am connecting it. So I'm connecting it here, nothing. But if I just put it on here, I don't know if that bridges too much. Put it on there, we get the interaction. So it's very interesting. No magnetic field on the outside. It's all on the inside contained. But of course, as the patent would hint to, it's not directly drawn, but the patent says it is a ferromagnet. Designed to be a ferromagnetic coil, so there would be likely some sort of metal beam or bar that would be on the inside that would interact with the magnetic flux of that medium. But that's just very interesting. I had someone do a request that I cover the bifilar coil. It's very interesting, especially as you have these opposing electric fields. That it's just interesting how it makes this sort of design, and you can. Just by simply switching the polarity, you can switch the polarity of the direction just by switching terminals. And it still creates this field where they go inward. And then once they go inward, your points up or points down, depending on the polarity of the field. So it's a very interesting design. A lot of mystery surrounds this patent because of Nikola Tesla was kind of a cryptic person when it came to these types of patents, where he kind of gives a reason for them, but he doesn't always give where he applies them. So it's very interesting in that regard. So I just wanted to cover it real quick. Some interesting physics are going on with this, and by plotting it out, you can kind of get an idea for the field lines of what they're doing and what those interactions may entail, and as far as how this works, so that you can get quite a bit of interaction here with just kind of a little bit of potential. And yeah, just thought I'd share, and hope you have a great day.